Welcome to Maths with Bob. Today we're looking at the trapezoidal rule, and we're going to develop the formula a little bit before we start to use it. But the first thing I think we need to look at is a trapezium. Okay, here we have a trapezium, the parallel sides. We have a couple of right angles in the corner. So it's got a flat end, or a flat bottom, actually, it'll turn into. So when we actually start to rotate this shape, you can see here, basically here we have it. So these are the trapeziums. They are going to be sort of stacked edge on end like this, and then they're going to form a sum to try and form the area under the curve. Okay, so let's go back and try and do this. So the first thing is, let's actually have a look at a function. Here we are. Here's a function. Let's actually, this is a y and the x-axis. Let's just do y0, y1, y2, and say y3. That should be enough, okay? So they're the heights, or they're how high they stand, the lengths of the parallel sides of the, they're all parallel. Okay, and let's actually make them a uniform width of h. So each one is h wide, okay, they're all h wide. So let's try and work out what the area would be. Well, the area would be h on 2, it'll be like y0 plus y1, okay, then it'll be h on 2, then we'd have y1 plus y2, then have a h on 2, we'd have a y2 plus a y3. Now you can see you can actually take out a common factor of h on 2, and you'll get a doubling up in the, so it'll be something like this, h on 2, it'll be a y0 plus a y1 plus a y1 plus a y2 plus a y2 plus a y3. Okay, and this is the, that would be the, if these are trapeziums, okay, okay, we obviously draw little tops across the top of the trapeziums. This would be the area under the curve at this stage, what an approximation to the area under the curve. So this gives us the general rule, which is that the integral from a to b of fx dx is approximately equal to, now h on 2, the width you can see, width on 2, is going to be now the first and the last, so I just write the first plus the last, plus twice some others. Okay. And in this case, you can see here it would be, in our case, it would be h on 2. It would be like y0 plus y3. Okay. Plus 2 times the sum of y1 plus y2. And you can see that there as well. Okay. So we're going to now apply this rule to a problem, and let's have a look at a problem. Okay, we're going to have a look at y equals x squared plus 1, like I did in a previous video. So we use Simpson's rule, and let's use the trapezoidal rule on this. And let's actually quickly draw it up again. We know it's about like this. We're going at 1, 2, 3, 4, 5, 6, 7, and we actually have trapezoidal rule. Okay, we want to, it's 6 trapeziums. Or 6 subintervals, and you can see here from x is equal to 1 to x is equal to 7. Okay, you could actually go to get the width, you could go 7 minus 1 on 6, which is 6 on 6, which is 1, but most of the time you can actually just see h, just have a quick look here, h is actually here, as you can just see it's 1 unit. Okay, so what are the heights? Well, to work out these heights, you have to sub the x values into the function to get the y values, or the functional heights. Okay, so f of 1 was equal to 1 squared, it's going into x squared plus 1 plus 1. F of 2 was 2 squared plus 1, and f of 3 was equal to 3 squared plus 1. etc. Okay, so the heights were 2, 5, 10, 17, 26, 37 and 50. 37 and 50. This is the y, the x-axis, and the origin here. Okay, so let's just apply the trapezoidal rule. Okay, so first up, we know that it's going to be the integral from 1 to 7 under x squared plus 1 dx. Now it's going to be approximately equal to, okay, so it'll be h on 2, which we know is 1. It'll be y0 plus y6. Now, let's have a quick look. Okay, let's write y0, y1, y2, y3, y4, y5, and y6. Okay, these are zero-based, actually starting at y0. Okay, so y up to, it's now y. First one is y0 and y6, plus twice the sum of the others, which would be y1 plus y2 plus y3 plus y4 plus y5. Okay, let's put the numbers in. Okay, it's approximately equal to, we know h is 1, so it's approximately 1 on 2, the first and the last functional values. That's at 2 and 50, plus twice the sum of these others. It's 5, 10. Okay, 5 plus 10 plus 17 plus 26 and 37. 26 plus 37. Okay, so we've got to double the sum of those. So it's approximately, let's have a look, a half of obviously 52 plus 2 lots of, I think it's 95. And that gives us approximately like a half of 242. Okay, which is approximately equal to 121, which is not bad considering the actual trapezoidal rule is supposed to be a little bit more inaccurate than Simpson's, and Simpson's gave us 120. The actual fundamental theorem of calculus gave us 120 as well. So we are pretty close with a nice smooth flowing curve like this one. Thank you for watching.